Hello, good afternoon. Welcome to the Lab 4. Uh, Before we get started, maybe we want to have a check of the Moodle at first, because we have released the specification last week for the assignment. Uh, just give me a sec. I want to open the page. Yep. So in the Moodle page, as you can see here, we have some term project specification and the details as well. So for these two files, maybe you want to have a check of this file in details. Uh, let's have a look. This is the specification for the term project. As you can see here, we have a map in a red box. That's the area you want to do the data collection for the phase one. And you have noticed that we have a building inside at this place. Do not go to the building. We only collect the data in the outdoor area. So only the outdoor area in here. And for the data collection is quite similar to the labs for today and last week. Basically, we just need to gather the information for your system and what's the SSID and BSSID and what is the Wi-Fi standard. What's the frequency, Wi-Fi channel, and signal strength, and etc. And have two additional things like public IP address and network delay. This will be covered this week, so you will have some idea how to test this. And for the public IP address and network delay, it's only for the unit-wide. But for the other SSID, you don't need to collect the IP address and the delay because you may not be able to connect to the Wi-Fi to test it. So for the phase one, we need to collect all the SSID in that area instead of only the unit-wide. Is that okay? And for the GPS stuff, we also need to have the location, right? So maybe you need to use your mobile phone to gather the GPS information, as our laptop may not have the GPS device and cannot get the accurate location during the collection. So it's better to use your mobile phone to do the collection. Actually, you have multiple choice to do in your mobile phones. For example, the coordinates or GPS checks. Let me show you. GPS checks. So if you can write your own program, but otherwise you can use some existed GPS softwares to do this one. But this one is a paid software, so maybe just use the free version. This can check the location and the time when you do the collection, and it can export as a CSV file. Of course, this one is not the only one. You can have a check of all the uh, application, but basically just the same idea. All you need is the latitude and longitude and the accuracy. And for the submission, you can refer to this table and a template file in the Moodle. Uh, so your CSV file will contain these columns, and at the right hand side, you can see some examples of them. So just make sure you are submitting a CSV file in the correct format. And at the end of the file, you will be able to check how we judge your submission, like in the marking details. Like for the phase one, it's basically just the data volume and distributions. Just long word short, you may spend at least 1 week, like for example, couple days a week, and maybe one time for each day, and try to cover different time. Like for example, in the afternoon or later afternoon or evening or morning, you try to cover all the like the time during the day, and try to collect in different days across in a week. And for the data quality, which means you need to have a high quality data, make sure you follow the guideline of the specification to have the same column, and every column have the correct like correct type. For example, it's if it's the strings, then you do not put any other thing other than the strings. If it's float, do not put any strings in the column. And at last, we have a report. Just basically tell us how did you collect the data and how to repeat the steps. So should not be very long. Just confirming, we are supposed to run the Python file to gather all the information, then make spreadsheet with the collected information. Uh, yes, really depends on you. You can collect in separate file and then merge them into one. That's okay. Yeah, so I think that's it. Please let me know if you have another question. And for the like data collection time, it's totally fine if you can only cover like let's say after hour or during the working time, it's totally fine. But just try to make a good volume and distribution. For example, you are not able to come to the campus before 8 before 12 p.m. That's totally fine. You can just collect the data after 12 p.m. But try to make it different days and try to just make your data have more details. So when we judge your submission, basically we will go to this map and try to plot which location have you got any information. Like because we already know the latitude and longitude, we know the location. So we will plot some dots in the graph and see if you have covered all the area for this map. And we will also plot a time span graph. So show you like how many times have you collect the whole area and like what's the duration and etc. Sorry, how can we combine the GPS and Wi-Fi information using time? Yes, it is correct. So one of the issue is to do the time synchronization. It's a bit challenge to match them, right? Is there a way to retrieve data from without copy paste from the GUI? I don't think they have a way to do this. So for the Mac, you may need to manually create some data. Like for example, in the Mac, you will not be able to retrieve the, let's say, channel width automatically. Then in this case, you have two ways to do this part. The first part is to calculate the channel width based on the speed or other information or on the channel. If only one channel is used, usually the width is the fixed, usually 40 megahertz. So for 2.4 gigahertz, I remember it's 20 gigahertz and 40 megahertz, 20 megahertz and 40 megahertz. And for 5G should be 40 and 80 megahertz. So you can either create a table in your program to match them by SSID, or you can do the calculation for the channel width based on the channel and the speed. Do we use the Lab4 method for determining frequency for Mac OS? Yes. So for Mac, you are not able to fetch the band directly. You will not able to tell if it's 5 gigahertz or 2.4 gigahertz. But while the channel, you can see what's the uh frequency of that. Let me show you. Just give you some direct idea. Give me a sec. Uh, for the 2.4 gigahertz, for example, can you see my stuff in window here? You can see for 5G gigahertz in Australia, usually the channel is from 36 to 64 and 100 to 186, 168, 5, sorry. And for the channel 2.4, then you can see usually from channel 1 to 11, sometimes we come to 14. So you can see the channel can basically tell you what's the frequency. So we only need to find a few spots that can cover all the Wi-Fi information along the line. Uh, couldn't tell because, for example, you you collect the data like this. Uh, so what we want you to do is to walk around, l- like walking around in this area and try to gather more information like this. This is just an example. No, I'm saying that you have to do it like this, exactly the same, but just give you some idea. So you starting from here and then you keep walking and try to cover all the area in the campus in this red box. And and then we can consider this one is a like data collection session. But in another way, you can say, maybe I split this part into different points. You can say, maybe I collect at this point, and then I come to this part, and then I stop here for some testing, and do some tests like this, and here, and then I stop at here, and here, and here, and here. It's okay. I mean, both methods is okay as long as you can create a high quality data set. Just try to cover them all the area, especially for the corner. Is that okay? So you can either like choose some spot in the map and stop there and do the collection and then move to next spot, or you can develop a script so you don't need to stop and wait. can just keep working, and the script will do the test. Uh, is it okay we only collect the data for Uni-wide and Uni-ROM? Because other might be a lot of other Wi-Fi, like 10 or so time collecting multiple days can make it a bit difficult. But I think for the data collection, if you have any script, it should not be a problem if they have many access points. So we are expecting you to collect all the surrounding SSID and BSSID. Maybe collect information every 20 meters. Also, will it be acceptable for some app Wing5 to collect those information? Definitely, you can use any tools to do the collection. And I wouldn't say 20 meters is bad, and I'm not pretty sure it's good or not because you haven't get it yet. If you have any outputs, maybe I can judge if it's good or not. And any tool is available for you. All we need is the data set. So we don't care how you do the collection. We just want a clean and clear data set. Okay, I think that's enough for the assignment stuff, right? Let's jump back to the lab 4. Lab 4 is basically following the guideline of the assignment. So that's the reason why I want to spend some time on the assignment at first. So in here, you will see how do we test the latency and jittering for this one. And please give me a sec. Let me run the terminal to run the command. Yep, sorry, a bit delay on running the Windows terminal. And here you can see I try to run the command for google.com, but in the specification, we are running the in command for this CSE server. So for this one, just run the, I just want to do the demonstration based on the Google server. And with this information, you can see we are sending a packet, we are sending 20 packets to google.com. It's ICMP packets, which means we are requesting for echo from the Google server. So we are sending a packet to the Google server and get a response. So you can see at here, we have a time at this place. We have a time in here, which is the RTT, round trip time, which means that we take 17 milliseconds to send a packet and get a response. So it's a round trip time. And at the right hand side is time to leave. And in the bytes, we send 32 bytes packets. And in here, you have noticed I'm using another parameters because I'm using Windows. If you are using Linux or Mac, you use C to specify the count for the numbers of packet that you want to send. If you are getting timeout issue for the CSE website, maybe you just use unsw.edu.au. Yeah, this is because it's an DNS query issue. Like as you can see in here, actually we are sending a packet to this IP address. So even I specify we are sending to google.com, but this command will first figure out what's the IP address. So it will do a DNS query for the google.com, and it will figure out, oh, its IP address is this one, and then we can start to send in the packets. So if you're having some issue to send to the csv.uns.w, that's okay. You just send send to this one, or you can just check what's the IP address for csv.unsw.edu.au. You so you can do in different ways. Either you figure out what's the IP address, or you can just use the UNSW website directly. And now we come to the next step. How to plot a graph. Like in here, you want to plot a latency change. So in here, I want you to do the plot with a line chart. So how, does anyone have any issue about this one? I can show a demo code or show you how to do it if you want, but it should not be very hard, right? Maybe I have a quick demonstration on how to extract all the information. For example, in here, so at left-hand side is data, right-hand side is the Python terminal. So we just store the data into here. And now we try to match all the time, right? So we use regular expression dot find all time equal to some digits, at least one digits, millisecond, and with the data, we can see that's the whole list. Or sometimes it got timeout, right? It got timeout. We also want to match if it's timeout. So we just do it again. We want to have this one. This one, we want the digits and or timeout like this. But where's the timeout? I will leave the question to you. So in here, I don't match the timeout, but try to do it by yourself. I'm not pretty sure if I can match timeout with this regular expression. I think maybe I put something wrong here. Uh, should be something like this, I think. Like timeout. Oh, doesn't work. Never mind. I, I didn't figure out how to get a timeout. Uh, let's just say we can match thing like this, and I just want to keep the digits in here. Seems not very accurate in here. It's plus, sorry. So now we get a list. So with this list, we can put into our very small program in here. So we just use a very simple program. This is the information I extracted from the left-hand side. And then I just use the seaborn to plot it. And you can see the output should be something like this. That's the fluctuation of the delay. Is that okay? If you want, you can have a screenshot, but basically you can see it's pretty simple, right? And how I match the stuff is just using this one, but this one doesn't include the timeout. So if timeout, you can specify the value as let's say 2 seconds or more than that. And that's the task one. We just want you to know how to test the latency and analyze it. So you can use it in the assignment phase 1 and phase 2. And the second one will be more practical for our phase 1 assignment. Basically, you need to plot a table like this and export as an CSV file. So how can we do this? I think maybe everyone will have some idea how to write this program because in Lab 3, we done a similar one, right? But this time it's not only for the unified or personal hotspots. This time we are showing all the SSID around you. Like you have unified, you may have different BSSID for the same SSID, right? And you may also find different SSID in the same environment and just show them all in the table. And at the end of it, output as CSV file. Uh, uh, does anyone have any idea how to like load the CSV file or save as a CSV file? So, yep. Mm, so, you can either use the CSV library or use pandas library. You can choose any of them to do the like CSV file manipulation. Let me try to open one CSV file. So let's say you already have one file in your hand, for example, the templates. And let me open the templates. So we use data frame equal to pandas dot read CSV. That's how we read the file. Just need to find the file in here. Just give me a sec. I need to find a file. This one. And you can see the shape of the data frame. We have 2 rows, 17 columns, and you can show the table like this in the Python script. And you can also print all the columns. Columns include time and OS. Let's print out the times. It's just how you use a dictionary. You can see that's all the times in the table in the CSV file, and it will also specify what's the date, the type of it. So it's recommend to use pandas to manipulate your data set. It will be easier, and you can make sure the type of the column as well. And if you have no idea what is pandas, maybe I can recommend a 10 minutes tutorial for the pandas, 10 minutes to understand how to use the pandas. I will send it in the chat. Just like the regular expression, you may have no idea at very beginning, but it's very useful tools when you do the programming stuff. Basically, it can help you to manage the data set easily, like this. So if you have time, just go through it. Or if you feel comfortable with the CSV library, you can also use CSV library. Or you can use Excel as well. Just make sure the format is correct. And let's say if you already have a data frame like this in pandas, so all you need to do is to say to CSV file like this. You just need to run the function and like my sample.csv, just run this function with the file name and press enter. Then your CSV file was created. My sample, let me open the file. And here are the saved CSV file in Excel. As you can see, that's how we use pandas to create a file. Should be very easy. And maybe in the future, in the assignment help session, if you want to know more about this library, I can have a quick demonstration on like how to add a new row or how to delete some rows or how to manipulate the data set a little bit on the demonstration session. By the way, we have some demo session, no, it's help session for the assignment as well. I just want to show in here. Yes, you can see we have some help session on Wednesday, Friday, and next week Wednesday. So this is for our phase 1 help session. If you have any question for your assignment, like you have some trouble with your collection, or you are not sure what is the specification, then you can come to a help session. Or if you don't have any question, you can also come and have a look. And it will be online session just like this, and all the recording will be uploaded. Let's see what else. I think that's it for the lab 4. Basically, just want you to know how to collect the data and test the performance for our assignment. So this one will be fairly easy for you and will be related to our assignment. But from next week, our lab session will more related to the lecture content. And please let me know if you have any trouble with the lab or lab 3 or the assignment. I have a question about the marks of labs and assignment. When and where can we get them? Thanks. Oh, for the labs, you will be able to see the results by today for the lab 2. So usually we will release the results for the labs within 1 week. So you do the submission on last Tuesday, then we will release before last Tuesday. For lab 2, you will be able to have a check by the end of today. And for the assignment phase 1, you will be able to check the result at week 6. Because in here, as you can see, we need to do the submission. It's not this file, I'm sorry. It should be in another file. We have 2 specifications. In here, this one, overview. So we are going to do the phase 1 submission on week 5, at the end of week 5, Friday. And then in week 6, at the end of week 6, you will be see the result for the phase 1. And for the marking rubric, so how can we mark your phase 1? You can refer to this part, phase 1, marking details. Let's try to follow the first one, which is the 4 marks. Try to cover in different days, cover well in the space, and all the SSID. So not only the unit-wide, but also all the other surrounding access points. And for the data quality, just follow the format instruction in here, then it should be fine. And yes, just let me know if you have any trouble. And the Lab4 is basically helping you to understand how we do the assignment, and we want you to start by this week. So maybe you can try to do the task 2 today and see how it goes. Then you can try to bring your script to walk around in the uni and get some output, right? And then you can use the CSV file as your phase 1 submission in week 5. Is that okay? And what else? Uh, does anyone feel comfortable with the quiz as well? Like for the quiz, how's the quiz going for everyone? And just let me know if you have any trouble with this course. And yes, I will stop recording so you can share your screen if you have any trouble.